Okay, start number 2. So we have y is 11 to the x, and we want 1, 3, 3, 1 to the x. Well, if you play around with powers of 11, you get that that's 11 cubed to the power x, and look and put it in brackets, times the powers, so 11 to the 3x. And again, 3x could be written as x times 3. Here, just write x3. Remember, times means brackets of powers. So that's just y cubed. Yeah, hopefully you'll be able to jump straight from that step to that step without needing these steps. Next one, 11 to 3x plus 2. So that's 11 to 3x times 11 to the 2. So plus in the power means times, remember. So that's from the same logic as before. That's y cubed times 1, 2, 1, which we write as 1, 2, 1 y cubed. And then 1 over cube root of 11 to the power x. Well, we can write that as 1 over 11 to the third x, which we can write as 11 to the minus the third x, which we can write as 11 to the minus the third x, which is, from the same logic as before, y to the minus a third. Okay. Second one, we have an equation of a curve y equals 2x4 take away 1 cubed, and we've got a point x equals minus 1. So straight away, sub in x equals minus 1 to get what y is. So that's 1 times 2 is 2, 1 is 1, 1 cubed is 1. We'll just use calculator. Okay, we want the tangent, so that means we need the gradient. So dy by dx is the power to the front, take away 1 from the power, but I need times by the derivative of the bracket. That will be my u substitution. So that differentiates to 8x cubed, which that simplifies to 24x cubed, 2x4 take away 1 squared. Sub in x equals minus 1 into that. So that gives me minus 1. That gives me 1. So it's getting m equals minus 24. Jump a step, I should call that dy by dx, and it's m because it's a tangent, so I don't have to do negative reciprocal, so it's just that. Then sub it into y minus y1 to get y minus 1 equals minus 24 times x minus minus 1 to x plus 1. And then write it however you want. So I want to expand this bracket to minus 24x minus 24. I'm going to take everything to one side. So 24x plus y plus 23 equals 0. Okay, third one. We have theta is between 0 and 360, so in degrees. I've got sec squared theta is 3 times tan theta. So I need to get them into the same trig. So there's no point of changing that into 1 over cos and that into sine over cos, because I'm then going to get a mixture of sines and coses, which still will work, it's just going to take a while. Instead, use a new rule that sec squared is 1 plus tan squared. Take everything to one side. And your favorite is quadratic to the skies, where y would be tan theta. So you get y squared minus 3y plus 1 is 0. But I've deliberately made one that doesn't factorize, so you'll have to use your calculator to solve it. So we have 1 minus 3 and 1. So we get y equals 3 plus or minus root 5 over 2. Now remember y, that was tan theta, so tan theta equals 3 plus or minus root 5 over 2. So to get your answers, you have to go back onto here and do tan minus 1, or then type that in. So 3 plus root 5 over 2. So That's, what did I say, nearest degree? So that one would be 69. So we have 69 and add 180 to that, because that's the rule for time number. We add 180. And then all I'm going to do, look, instead of typing it all in again, I'm just going to go back to my original, change that to a minus. And then since I've used the answer button, that second one automatically changes for me. So I get 21 and 201 degrees. So there's my four answers. And remember, you can use solvent to check. Fourth one. Now these ones, as soon as you get your head around these are straightforward. So we have un plus 1 equals un squared minus 1. And the first term is minus 1. So the second term, well, if I sub minus 1 into there, get minus 1 squared minus 1. Minus 1 squared is 1, take away 1 is 0. So the second term, 0. Third one, so I sub 0 into there, so 0 squared minus 1 gives me minus 1. Sub to get u4, I would sub minus 1 back into there, which will give me 0. So I'm going to get minus 1, 0, minus 1, 0, minus 1, 0. It's a periodic sequence, periods 2, and I want the sum of the first 200. So remember, that means u1, add u2, add u3, add u4, all the way up to u200. So that means I'm going to get 100 lots of minus 1 and 100 lots of 0, which just gives me minus 100. And then the last one, the displacement of a particle of mass 0.5 kilograms is given by x is T5 plus E2T. So it's variable, so I'm going to use D, B, A. Find the force acting on the particle after 1 second. Well, for force, remember I need F equals ma. So I need acceleration. So to get from D to V, I'm going down, so I'm going to differentiate. So 5T4 plus 2E2T. Then to get acceleration, differentiate again. So 20T3 plus 4E40. So that's my acceleration. So after 1 second, I'm going to sub in T as 1. I'm going to get 20 times 1 cubed plus 4e to the 4 times 1, which just gives me 20 plus 4e4. Yeah, I'm not going to have my calculator yet. So that's 20 plus 4e4. If you do have the calculator, just remember to store it or use the answer button. So to get the force, I'm going to use F equals ma. So F is 0.5 times 20 plus 4e to the 4, which is 10 plus 2e to the 4. So 10 plus 2e to the power 4 gives me 119. Wait 2 seconds. Just spotted there. For some reason I put the power as 40. That should be 2t. I'm hoping you spotted that before me. So that should be 2, that should be 2, that should be 2 still. So I'm going to change that. As I said, that force seems very strong after 1 second. That's better. 24.778. Now, since we haven't used G, we give it 3 significant figures, 24.8 equals 3 significant figures.